Hello, and welcome to Backer Breaks It Down. In this episode, we are going to explore some angle pair relationships, mainly those angle relationships formed by perpendicular lines, as well as complementary and supplementary angles. First off, adjacent angles. Adjacent angles are two angles with a common side, a common vertex, and no common interior points. For example, angle DEG and angle GEF are adjacent angles. Perpendicular. Lines, rays, or segments can intersect at right angles, and we say they are perpendicular. Notice the little symbol looks like an upside down T, also looks like two right angles, but that's the symbol for perpendicular. So if you're given that segment DE is perpendicular to segment EF, you can conclude that DEF is a right angle, and thus DEF is 90 degrees. Complementary angles are two or more angles whose sum is 90 degrees. So those complementary angles can totally be adjacent, but they don't have to be. And supplementary angles are two or more angles whose sum is 180 degrees. They can once again be adjacent, but they don't have to be. So find the measure of the complement and the supplement of a 43-degree angle. So remember, complementary means they add up to be 90 degrees. So 90 minus 43 gives me 47 degrees, and that's the complement. Supplementary angles add up to be 180. So subtract 43 from 180, you get 137, and that's the supplement. So let's say you're given that ray BA is perpendicular to ray BC. What that means is that angle ABC is a right angle, so it's 90 degrees. Now they tell us that the measure of angle 2 is 3 greater than twice the measure of angle 1. So let's say that the measure of angle 1 is x. 3 greater than twice would be 3 plus 2x. So we're saying the measure of angle 1 is x. We're saying the measure of angle 2 is 3 plus 2x. And we're saying that the measure of angle ABC is 90 degrees. So if I add up these two angles, I'm going to get 90 degrees. So we're looking at 3x plus 3 is equal to 90. And then we're just solving this equation. So 3x is equal to 87. Which means that x has to be equal to 29. Now make sure you're answering the question. Find the measure of each angle. Well, we know that x is 29, so that's easy. And as far as angle 2 goes, whoops, sorry about that, I can simply subtract 90 minus 29, and I get 61, and that would be the measure of angle ABC. Now let's talk about the algebraic connection. Let's say x represents the measure of the angle. Then 90 minus x would be the measure of the complement, and 180 minus x would be the measure of the supplement, which is what we did in example 1, right? So let's make it into a word problem. All right, so it says that the measure of the supplement of an angle is 60 less than 3 times the measure of the complement. 60 less than 3 times the measure of the complement. So let's write this as an algebraic equation. The supplement. Remember, whenever they say supplement, you want to write down 180 minus x. So we've got 180 minus x is, that's your equals, 60 less than 3 times the complement. Complement is 90 minus x. So we have 3 times 90 minus x. And it said it was 60 less than, so minus 60. So this is our equation. They say supplement, we write 180 minus x. They say complement, we write 90 minus x. And then we fill in the rest as described. So now we simply need to solve this equation. So we're going to distribute. So we have 180 minus x is equal to 270 minus 3x minus 60. And then it's time to combine like terms. So we have 180 minus x is equal to 210 minus 3x. We should get the x's onto one side of this equation, get the constants onto the other side, and then we can solve. X is equal to 15. And then make sure that you actually answer the problem. This says find the measure of the complement. Remember that the complement is 90 minus x. So that means the complement is 90 minus 15, which makes it 75 degrees. So perpendicular, we're talking perpendicular creates right angles. Right angles are 90 degrees. Also 90 degrees are complementary angles. They add to be 90. And then supplementary angles are angles that add up to be 180 degrees. And that's how Backer breaks it down.